Page 192, number 21. F of x equals x times, I'm just going to rewrite that as x plus 3 to the 1/2 because I'm guessing a derivative is in my future. 21 says, find the points of inflection, discuss the concavity. I don't like that instruction. Like it wants you to write some essay on concavity. I think it just wants the concavity intervals. So we're not really going to discuss. We're just going to tell them where it's concave up and where it's concave down. Both of these are second derivative things. And intervals suggest a number line. But point of inflection is a number line too, because we're looking for where it changes from positive to negative. So it asks for two things, but it's going to be the same process to get both of those things. So let's find the second derivative, check where it's 0 or undefined, put those on a number line, test the intervals, and then we'll be able to answer this question. First, we get to do product rule. And I'm guessing we'll get to do product rule again, but one step at a time. So derivative of f is 1. Derivative of g would be 1/2 x plus 3 to the negative 1/2. And then don't forget the chain rule, although this time it's just 1, so if you had forgotten the chain rule, you'd be okay. But in general, especially if there's a parentheses there, we need to be thinking about chain rule. Let's clean this up a little bit. 1/2 square root x plus 3. Again, I go back and forth with the 1/2 and the square root. The square root looks better, but the 1/2 is better for derivative, so I don't even know if that was the best decision because we're going to need to take another derivative in a minute, but we'll cross that bridge when we get there. Product rule. So first times derivative of the second. Actually, I'll go all the way to this one. So x over 2 square root x plus 3 plus the other way around, square root x plus 3. Yeah, I've got choices now. I need to do a second derivative. That part's not a choice. I can do a second derivative as it is, which would require the quotient rule. Or I could add these two. That would still end up requiring the quotient rule. But I think it's going to work out better if we would add these two together. So let's get a common denominator and just make it one fraction. We'll still have to do the quotient rule, but I think our answer will be better if we clean it up before we take the derivative. We'll see. Maybe I'll be wrong. So x plus 2 times x plus 3 all over 2 square root x plus 3. So that would be 3x plus 6 over 2 square root x plus 3. Okay, that doesn't look too bad. So I think we made the right call in cleaning it up first. Now we get to do the quotient rule. What a lovely problem. Product rule and quotient rule. So f prime is 3. That's easy. G prime, again with the square root stuff. So 2 times 1/2 times x plus 3 to the negative 1/2 times 1 if you want to include the chain rule there. I guess we'll clean that up again. 2's cancel. 1 over square root x plus 3. Second derivative. Again, got to get the second derivative because I'm talking about concavity. Gf prime comes first. So 6 square root x plus 3 minus the other way around, fg prime. Oh, this is going to be lovely. Fractions and fractions. 3x plus 6 over square root x plus 3. All over g squared. Yuck. If it had only asked for a second derivative, we would stop there, right? Safe stop, I'm good, thanks a lot. There's your second derivative. But it wants us to do something with that, so I can't really stop there. I need to keep going with the algebra to clean that up, because I want the zeros of the top and the zeros of the bottom to put on a number line. I think I would first get rid of this fraction and fraction business by multiplying everybody by square root x plus 3. And, I get the extra bonus of, on the first term, the square root goes away. On the second term, the square root cancels. And on the bottom, let's see how I want to write that. 2 squared is 4. And then x plus 3 and square root x plus 3. I don't know if that's the best way to write it, but it's a way to write it. 6x plus 18 minus 3x minus 6. So 3x plus 12 over 4 x plus 3 square root x plus 3. So there's a cleaned up version. May not even be the best version, because we could combine this and make that x plus 3 to the 3 halves, but I don't know that that's really even necessary. So it's equal to 0 if the top is 0. So x equals negative 4. There's one of our, again, they're not critical points because we're dealing with the second derivative, but it's kind of the critical point of the second derivative. The second derivative is undefined if the bottom is 0. Well, that looks kind of weird, but looking at it, x equals negative 3 would be a problem. So I've got two values, negative 4, negative 3, which means I'm going to have to test negative 3.5 to just further complicate this problem. And then I'll test 0 and negative 5 into the second derivative, because I want to know where are we concave up and concave down. The good news is I only care about positives and negatives. So negative 15 plus 12 is negative 3. 4 times negative 2 times the square root of negative 2. Uh-oh. I can't do that at all. So that's not, there's nothing going on over there, because there is no second derivative. I can't take the square root of a negative number. Negative 3.5 times 3. Oh, lovely. That'd be negative 10.5. Plus 12 is positive. 4 times negative. I'm getting lazy, but it's okay, because we only care about positives and negatives. Square root of negative 0.5. And we got the same issue here. That part's gone. If that's bugging you, go back to the original and see if you can figure out why that is. Square root of x plus 3. Well, anything smaller than negative 3 was going to mess this up anyway. So that's why we're getting these weird answers over here, because we weren't I guess if we'd have really been careful, we could have noticed that there was no function over there to begin with. Plug in 0. 3 times 0 plus 12 is positive. 4 times 3 times square root of 3 is positive. So the second derivative is positive. So we are concave up from negative 3 to infinity. And I guess there's no points of inflection because it never changed. It's wherever that graph exists, it's concave up. So I guess we should explicitly say that. No points of inflection. Right? I'm going to graph that and see if that matches. Because this one isn't too hard to type in. X times square root of x plus 3. And yeah, negative 5 to 5 is probably fine because it's not supposed to be negative 3 anyway. And I think it's supposed to be concave up the whole way. So moment of truth here. Okay, that is a weird graph, but it is concave up all the way, and there's nothing left of negative 3. So again, you want to always have a calculator, but you can use it. It wouldn't have helped you. I mean, it might have helped you a little bit on this problem, but really the only help is kind of verifying your answer.